Okay, all right. I gave everybody credit for. Let's see, what was that? 3.45. Okay, everyone got credit, but there was two or three of you that actually got the answer I was looking for. Now, everyone that got it correct got credit, right? And most of you did, but some got the answer I was actually looking for, and it wasn't the answer that was in the back of the book. Okay, it wasn't the answer in the back of the book. So what I'm going to do, everyone got credit that answered it, at least according to the back of the book. There is two or three that answered the way I would actually expect it. So it means that they probably had a little more experience with this type of thing, actual practical experience. So that's why I gave everyone credit. But the three that got extra credit, well, they got extra credit for getting the answer I was actually thinking of. So I'm not going to do that problem here, but what I will do is give extra credit. All right, if you want to send it to me in my inbox, okay, the alternate answer that I'm looking for is you're going to have to go back and think about this problem and think why it would be a different answer. Not a lot different, right? But there's a slight difference. And explain to me why, okay? There's possibly, in my case and a couple others, it would be a different answer. And give me that answer, okay? And then I will give you extra credit. And that extra credit is going to be 10 points, okay? And those 10 points will be peanut butter. So let's say you got a perfect grade, okay, on your next homework. I'm going to take and apply that 10 points. And let's say you're always 2 points short on your homework grade. And, I'm not just going to apply it to this homework. I'll apply it to all your other homework so that if for some reason you're getting perfect papers, except the last one is 10 points shy, well, I'll give you that 10 points. Okay? Or you're within two or three, or you're way off and struggling or whatever, I'll give you the 10 points. All I'm looking for is the answer. Okay? Now what I'll do is make it easy actually is I'll put it on a discussion post. And you won't be able to see other people's answers until you do your own, okay? And I'll let you. I'll put it up on a discussion, and you can give me that answer that I might be looking for, that two other people got, and tell me why. Now, if you have to get the right answer, and you have to give a good explanation to get the extra credit. That's it. Okay, that's just what I'm going to do. Okay, anyway, let's move on to the next problem. So that next problem is 3.46, okay? So 3.46, put this up here, 3.46, okay? 3.46 says this. A hexagon bar of steel is placed between centers on a lathe. Okay, placed between centers on a lathe. Let's see. The bar is 23.5 inches long. Okay. If the bar is machined for 1/3 of its length, how many inches of unmachined hexagon bar remain? Okay. So there are some things in word problems that are completely irrelevant. We don't even really care, okay? But it gives a nice description, tells a little story, right? So that's all it is. And the one thing that really is completely irrelevant to this problem is the fact that it's a hexagon bar. Doesn't really matter. Could be a round bar, could be a square bar that's being turned round on a lathe, whatever, right? But this one's a hex, okay? It's irrelevant to the problem. No one really cares. Now you don't because you know, okay? In case you didn't, right? Okay, so what does matter? Okay, there's things that matter. The hexagon bar itself is 23.5 inches long. So let's write that up on the board. 23.5 inches long. Total. That's the total length. Okay, so that's what we got. So next thing is what? What else do we know? The bar has been machined for 1/3 of its length. Okay, 1/3 of its length. So I'm going over this in this fashion so you see how we break down a word problem, right? So 1/3 is machine. Well, then you want to look, well, what's the question? Okay, fine. Okay, 1/3 is machined. How much is not machined, right? Okay. Now, I can look at this. Well, let me write that up first. How much of the bar is not machined? Now let's look at the word problem again and see how they said it. It's probably something very similar to this, and you want it to be, pretty similar to make sure you're not changing the problem, right? Okay, so let's see. And sometimes context is important. Here we go. Hexagon bar of steel is placed between centers on a lathe, okay? The bar is 23.5 inches long. If the bar is machined for 1/3 of its length, how many inches, this is important, of unmachined hexagon bar remain? So they worded it a little bit more specifically than what we have here. How much how much? We put how much. Better is how many inches. That's more specific, because if it was just how much remained unmachined, I can say, well, 23.5 inches long is a 1 bar minus 1/3, right? Yeah, that equals 2/3. My answer is 2/3. 2/3 of the bar is unmachined. That would be correct, but it didn't answer the question. How many inches are left, right? That's the key here, right? So you got to be a little bit careful about how you're framing your equation, okay? Now, again, there's more than one way to get to it. I'm going to show you the direct route, okay? So the next thing you do is, what am I looking for? Well, I'm looking for how many inches the bar is not machined, and that kind of gave me the answer. I'm looking for the 2/3. I don't care how many inches was actually machined. I don't care. I don't want the 1/3. I want the 2/3 that's not. I need to know how many inches that is. Okay? So how many inches is not machined? So this is a multiplication problem, okay? And it's similar to what we looked at before. I've got something 23.5 inches long. Okay, how much is not machined? Okay, so I multiply this, okay, by 2/3, and because I want 2/3 of 23.5 inches, there's that magic word, of, multiply, okay? I want 2/3 of 23.5 inches, of 23.5, 2/3 of 23.5 inches. There's the magic word. Sometimes you have to come up with your own word. Anyway, your own phrase to understand it, okay? But if you can plug that in, it's great. Okay, so 23.5 inches long. So it's a multiplication problem. So I got 23.5, and I'm going to multiply. 23 times 2 is 46, plus 1 is 47 halves. So I got 47 halves of an inch, right? And I'm going to multiply that by 2/3, right? 2/3. So, well, let's just cancel that out, and my answer is 47/3. Okay, but again, I'd have given you credit if you left it as an improper fraction, but it's better if you reduce it, okay? So I got 47. Well, how do we reduce it? We just divide. We do the problem. 47 divided by 3, right? So there's 1, 3, 17, 5, that's 15, right? And leaves you with 15 and 2/3. That's the answer. That's the answer. You're done, okay? Now, what would happen if we did this first? I multiply it by 1/3 and find out how much was machined. Wow, right? Well, that's 1/3. I need 2/3, right? I could just add that answer twice and get my 2/3, and it would work. You can try it. Okay, you'd get 15 and 2/3 if you did it correctly. But that's an added step. You don't have to, right? Done, right? You don't have to. That's 3.46. Okay. Let's see. What other fun ones did we do? Let's see. 3.46. All right. Let's do. I think it is. Let's see. 3. Where are you? Oh, here we go. Yeah, 3.50. Okay, and you know we're dealing with a little bit bigger numbers here, and it's this one. Let me erase. Let me erase. Okay, so we've got here 3.50. Okay, 3.50. Here it is, right? There's another fun one. They're all fun. They're all fun. They're kind of fun, you know, when you go through. 350. Here it is. Calculate the weight of 24 brass bars. Okay? 24 brass bars. Each of them are 8.5 feet long. Okay? Each bar. If brass weighs 39 and 4/5 pounds per foot. Okay? Well, there is information that they don't give you, and they don't give it to you because it's really not relevant to the problem. But sometimes there's nice to knows, right? We have to understand that brass that weighs 39 and 4/5 pounds per foot, okay, is a certain size. We know the length, right? The length is given as 8.5 feet long. But what is it? A 1/2 inch diameter, 1 inch diameter, or 2 inch by 3 inch rectangle? We have no idea, right? We know it's 8.5 inches long, and how 8.5 feet long, and how much the bar weighs. That we know, and that's all we need to know in order to do the problem. But sometimes there's a nice to know. So I'm going to throw in another extra credit, and this will be another 10-point extra credit in the same light as the other one, okay? And so what it means is that here's what I want you to do, okay? I want you to tell me the size, whether it could be round, could be square, it could be rectangular, one of those three. What size is of an 8.5 foot bar, weighs 39, 39 and 4/5 pounds. Now, in all honesty, you know, brass, they didn't say what alloy it was, because there's different alloys. You know, this type of thing. Alloys, remember, have more than one element in it. And we just kind of went through that in the other problem. But if you give me an answer, you tell me the alloy, and an alloy, let's say, for example, alloy of 1.5 inch diameter, 8.5 feet long is 39 4/5 pounds. Okay, that's fine. And that's all I need. And if you can give that, so some of you may have slightly different answers from the others, okay, depending on the alloy, depending on whether you're going round or square or rectangular, that's fine, okay. But you give me an answer that is correct, you know, based on what the information you give me, you get another 10 points of extra credit, okay, to go on your homework. And again, peanut buttered, okay, so if you're perfect up till now, you miss 2 on the next one, and then 4 on the next, and there I'll fill that up with a total of 10 points. Here we go. It's really not a bad problem, but it is getting kind of a big number, okay? So what do we know? Okay, we have 24 brass bars. So the number is 24 brass bars. Right? Am I in the way? Oh, I do. When I'm over here, I shoot, right? Directly in the way. Brass bars. Okay, we know that. Let's see. They're 8.5. One bar is 8.5 feet long. One hash mark is feet, right? And let's see, what else do we know? Let's see. This particular brass is 39 and 4/5 pounds per foot. 39 and 4/5 pounds per. That's that per foot. Okay? Don't get confused with division and all that stuff. Okay? Technically, you can find there's a division problem, but whatever. That's how we say per, right? 39 and 4/5 pounds per foot. Okay, and what are we finding? The total weight of 24 of these bars. Now, when you break it down like that, that doesn't seem too bad, does it? Right? So what's the first thing we're going to do? First thing we're going to find out is how much 1 bar weighs, right? And we're going to do that by multiplying this. There's 8.5 feet. This is 39 4/5 pounds per foot, okay? And so we're going to multiply 1 bar by 39 for 8.5 times 39 4/5 pounds, right? Let's say, for example, simplify it. Let's say it's an 8-foot bar, okay, and it's just 4 pounds, okay? We're just going to say that per foot, okay? So there's 8 feet, so we take that 8 and we multiply the 4 pounds. We multiply it 8 times, it's 32 pounds, right? That's how this works. Very simple. Same kind of thing, okay? So, but let's do the multiplication. So we have 8 times 2, 16 plus 1 is 17. So we have 17 halves. That's compound fraction for the length of 1 bar, okay? And then we have 39 4/5 pounds. Okay, well, we got to do a little addition here, or we got to make a compound fraction. 39 times 5, that's 45. 15, 19, add 4. So we have 199. Okay, so we multiply that by 199 over 5, right? And that's our problem. And there's no reducing. Forget it. Ain't going to happen, right? There's nothing there. Okay, nothing there to reduce. This is an odd number. 2 won't go into it. 5, even this way, it doesn't work. Prime number, etc., etc. So now we just multiply. Okay, let's just do it. All right, so this equals, right? So we're still finding the weight of a single bar, okay? So 199 times 17. Well, let's do a little fun, right? Let's see, what is 9 times 7 is 63. 63 plus 6 is 69. 7 plus 6 is 13. And then we bring down the 0, and then it's 199, right? 991, right? Okay, and we're done. So we go 3. There's 18. 9 times 3 is 12. 1 is 13, and 3, right? 3383, right? So we have 3383 over 2 times 5 is 10, right? So that's the weight of 1 bar. Well, when you divide anything by 10, move to the decimal point, it's 338 and 0.3. We'll get into this more, but it's just over 338 pounds. That's a heavy, that's a heavy piece of bread. That'd be interesting to see what the actual dimensions are along, of that 8.5 foot long bar. Okay, maybe it's a thick plate or something. Right? Brass is heavy anyway, so don't get me wrong. All right, so we've got this. We've got the weight of the bar. We can go through and say 338 1/3 pounds, right? We could do that, right? But if we do, we're just going to have to convert it back into a compound fraction to do the rest of the problem. So we're just going to leave it like this. Okay? Now we have 24 of these. Okay? 24. So we multiply the weight of 1 bar 24 times, right? Times 24. Let's put it in fraction form. So now we take this fun number and multiply it by 24. You can see it's going to, get fairly sizable. Okay? Okay, 4 times 3 is 12. 32, 33, 12, 13, 14, 15, 12, 13, right? Big placeholder there. 2 times 3 is 6. 2 times 8 is 16. 2 times 3 is 6 plus 1 is 7. 2 times 3 is 6. Okay? Add them up. 9, 11, 11, 8. Woo! Okay? So what we have here is equals, there. What we have here is 81192. 81192 divided by 10. 10 does what is 10. Okay? Well, remember, we do it that way. You can do the long division if you like and see. Let's do the long division. Okay, let's just do it. It's easy. 81192 divided by 10. Okay? 10 goes into 81 8 times. Do 80. Bring it down. 81 minus 80 is 1. 11, 1 time, right? 10. There's 1 again. 19, 1 time. Goes 10. And then you have 92 goes 9 times. So it's 90 minus 2 is the remainder. So it's 8119 and 2/10, which reduces to 1/5, right? So the answer is 8,119 and 1/5 pounds. There's your answer. Okay, that's the answer. All right. Okay, there it is. All right. I think I'll do one more. So, but I'm going to end this video, and I'll do one more.